Alright, so this is a quick lesson because hopefully you learned most of what you needed to yesterday. It's just a quick adjustment. As yesterday we learned how factoring makes solving easier, because based off of what we learned, if you have two numbers that are multiplying to be 0, as long as A is 0, it does not matter what B is, the answer is going to be 0. So one of the things we learned was that A has to be 0. The other thing we know about it is that if B is equal to 0, that it does not matter what A is, because it's going to work, because anything times 0 is 0. So the second thing we learned to do as we split our factors was that this was our answer. The question is, what happens if we try to solve the problem of A times B is equal to 1? Well, here's the problem. If I put 1 for A, the answer is 1 for B. If I put 2 for A, everybody thinks, well, of course that tricks it, but no, you would just do 1/2. If I put 3 for A, you would do 1/3, because 2 times 1/2 is 1. If you need proof, here you go. 2 times 1/2 is 1. It's the reciprocal. It would make it work. Anything you want. If you put the 2 over here, you get a 1/2 over here. If you put a -4 over here, you get -1/4 going with it. Whatever it is, there are so many numbers, so many number combinations that work, that it does not work whenever there is a number. And so therefore, that is just proof. Hopefully not. It's not a lot of proof, because we don't have time for all that, but there is proof, or that is proof, that you have to make sure your factors equal 0. And that is a simple thing to do. You just have to keep it in mind whenever you're solving by factoring. Actually, whenever you're solving any kind of problem, except for one that we're going to talk about, I believe, tomorrow. But again, let's look at some problems you're going to see in today's work. Because the adjustment is very easy, it's actually just algebra that you already know. What we do here is we see x squared minus 8x minus 2 equals -14. Based off of what we know, we cannot use algebra because there is an x squared and an x. So what we have to do next is we have to say, well, in order for this to work, this has to be 0, and all you have to do is add 14 to both sides and put the 14 where it belongs. This is a regular constant, so it'll go right there, which means we end up with x squared minus 8x plus 12 equals 0. And once you move everything over to one side, everything else is good. So again, I'm going to go ahead and get to the factors because I've already taught the factoring anyway. I believe this is x minus 2, x minus 6 equals 0. 6 times 2, 12, -2 plus -6. From there we go ahead and solve, which is your x minus 2 equals 0, your x minus 6 equals 0, which means that x is 2 and x is 6. And just to prove it, let's see if it works the way we need it to. So if we put 2 over here, we have 2 squared minus 8 times 2 minus 2 equals, and notice that we get -14. If I go back, copy and paste, turn my 2's into 6's, notice how my answer still works as -14. So again, the process of factoring works. You just have to make sure you add to your understanding of that it has to equal 0. It must equal 0. It has to. Alright. Other than that, same thing here. X squared plus 12x plus 31 equals 4. This is a positive 4, which we must, again, we can't solve using algebra because there's an x squared and an x. Can't do it with both. So what we're going to do here is subtract 4 to make it equal 0. We get x squared plus 12x plus 27 equals 0, and you do what you did yesterday, which is to factor. Again, I'm not going to cover the factors because I already know it and I already taught it. And again, if you need assistance, I think I gave you the directions on what to do. And again, that's not an insult. It's just saying that the information's out there. There's no need for me to do too much extra work. But again, 3 times 9 is 27. 9 plus 3 is 12, so it works. We will then go x plus 3 equals 0. X plus 9 equals 0, which means that x is -3 and x is -9. And that is where we are. Alright. The last type of problem you're going to see that has to do with this process is something like an application problem. And it's not just for this type of problem. It works actually in a few of them whenever you have different things like this. It's talking about the area of a rectangular garden being 72 feet squared. If the width is 3x and the length is x plus 5, what are the actual measures of length and width? So what we have here, you got to understand that area is length times width. And so you could put it in whatever order you want, but what I'm going to do is I'm going to use this formula, and I'm going to kind of change that around here, but I'm going to plug in what I know, which is that the area is 72, and that this times that is what I'm going to do to make the area. because the width times the length is going to make 72, which means that right now I could factor if this was 0, but I can't right now. So what I have to do is I have to unpackage this, put the 72 in, and then refactor it again. So that is again where you need to make sure you understand the process that's going on. So we're going to distribute this first to be 3x squared plus 15x, because again you distribute that 3x to both numbers. Again, 3x squared plus 15x. Now what we're going to do is move our 72 to where it belongs, and because there's no constant, we end up with 0 equals 3x squared plus 15x minus 72. Now this is a big problem here. What we're looking at here is 72 times 3, which is a number that makes 216. But what you have to learn how to do is whenever numbers get big like that, just check to see if, especially on word problems, just check to see if there's anything that goes into all three. And there actually is. All three of these are divisible by 3, which means that you could actually do something else, which is to factor off a 3. But I'm going to actually work it out like we have here, just to show you that we still can use what we learned. So this multiplies to make negative 216 and adds to make positive 15. So again, we make the tree for 216. 2 times, I think, 108, 6, 7, 8, 9. So it goes into 3. 3 times 72, still not it. 4 times, if it ends in, if the last two digits are divisible by 4, that's how you know it's divisible by 4. Just like if you didn't catch what I did, if the sum of the digits is divisible by 3, you can divide it by 3. Of course, you know if it's even, then it's divisible by 2, so on. But again, 16 goes, so I know it'll work. 4 goes into 21 5 times, with 1 left over. Goes into 16 4 times, so 4 times 54. It does not go into 5 because it should end in a 5 or a 0. Not sure about 6 though. I think it is. Yes, it is, because 6 goes into 21 3 times with 3 left over. And 36, still not there. 7 is not it. 8 is 1656. Yes, it is. So 8 would go in 2 times 7. Is that it? Yep. 9 goes in because it adds up to 9. The 9 trick is the same as 3. If you add them up, 6 plus 1 is 7 plus 2 is 9. That is divisible by 9, so that would be 2, because that would be 18, and 36, 24. I think that that's my numbers, because if the sign is negative, it means I'm subtracting, and I think those two make 15. So I think I can stop. Again, you do not always need to finish it, especially if you practice doing it and the process works for you. This tells me that my big side is positive. Just to make sure, I put the signs to make sure. This tells me the signs are different because it's a negative 216, and when I do negative 9 plus 24, notice that I get 15, which means that those are my numbers. Once again, you have to remember that because there's a number in front, I can't just do like I did here where I find the numbers and put them in. I actually need to do the fraction to keep myself online, so I'm going to do 3x over negative 9, 3x over 24. This turns into x over negative 3. This turns into x over 8, which means my factors are x minus 3, x plus 8. Now, in terms of official factoring, this is wrong because, as we learned, x times x is not 3x squared, and so you would need a 3. But in terms of answering a question like an application problem, that really doesn't matter. What we have here is two answers. We have x equals 3. We have x equals negative 8. And again, I'm doing that without plugging it in because I don't think that's really necessary. You understand we're going to do x minus 3 equals 0 and x plus 8 equals 0. So these are our two answers. Now here is where you have to be careful, which is why I spent most of my time on the application problem. It gives us two answers. And remember that in any quadratic equation, you can have two answers. But let's think about what this means. If I plug a negative 8 in here, 3 times negative 8 is 24. That means the width is negative 24 feet, which does not make sense. And so because it's an application problem, this answer does not work. You do not want to use the negative 8 because in terms of application, negative numbers are not allowed. Also, your answer is not 3 because it wants the actual length and the actual width. So what you have to do now is actually find those numbers. I'm sorry, I'm running out of room. Probably shouldn't have done all that work there. But based off of what they said, the length is x plus 5. Well, if x is 3, 3 plus 5 is 8. Based off of the problem, the width is 3x. If x is 3, which we see it's right here, it is, then the width is 9. 9 times 8 is 72. Therefore, we know that it worked. And this is what you're going to be given the computer, is both of those numbers there. So again, go ahead and use the rest of the time. Try this stuff out. I don't think this assignment is large. I think it got like 10 problems before I open the door for you to go back to practice other things, because this is it's an important part of the chapter, but it's not the most important part. The most important part is all the other three sections that you've been working on, 3.5 sections you've been working on. So go on over to Math Excel and again continue working me like crazy so I can answer your questions and you can continue to get ready for your first test right before spring break. Good luck.